Let's solve Max Exam Math A 2014 question 1.5. Okay, so this is a reoccurrence question. Okay, now I'll be honest, I can solve reoccurrence from first degrees, understanding what I'm doing actually, but this is a reoccurrence from second degree. Now I can solve a second degree, but I know like the method, I know the steps we take to solve them, but I don't understand them very well and why we are doing them. Maybe in the future, when I understand better, I will do a second video about this question. Okay, so look, when you have, how can you know this is a reoccurrence of second order? Because this is the first thing you need to see. So and I will see if I can find some videos to explain this, to put them in the description. Okay, so look, a reoccurrence is, you have a k. So if the normal progressions that we know, the arithmetic and the geometric, you usually have a k equals to a1 plus or minus n minus 1 r, right? It doesn't, you can say any term just knowing the first one. Okay, in the reoccurrence examples you can say any terms, but by using the terms you know before it. So look, in the reoccurrence from first order reoccurrence, you only need to know the 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 number that comes before the one that you want to know. So let's say you want to know ak. Okay, ak. So if it was depending only for ak minus 1, this would be a first degree reoccurrence, but it depends also in another number, the second number that comes before it. So what does this mean? And he tells you that a1 is equal to 1 and a2 is equal to 2. So look, what does this mean? If you want to find a3, ak3 is minus 4 ak minus 1. So k is 3 minus 1, 2, right? So a of 2 plus 3 a k minus 2. 3 minus 2 is 1. So this is equal to 0, right? He told us this over here, equals 0. For k bigger or equal to 3, okay? So this is why we chose k3. So this is equal to 0. Now look, a2 is equal to 2. It could have been another number, but the exercise gave us this, okay? So the exercise gave us these values over here, okay? So a3 is equal to what? Let's send them to the other side, these. So 4 multiplied by a2, which is 2, plus 3 will go to the other side, minus 3, multiplied by a1, which is 1. So we will have that a3 is equal to 8 minus 3, so it is 5. So this is a second order reoccurrence, okay? So the way to solve these questions is like this. We are going to use the quadratic equation. Look, we can say that ak is equal to some constant 1 multiplied by r to the n, r1 to the n. I will say what are r to the n's, okay, in 1 second. So 1 second, let's say the constant r in blue, okay? So you can represent them by this, okay? This is multiplying, okay, plus a constant 2 multiplying by r2 to the n. And in 1 second I will tell you what are the r1 and r2, okay? So this is r1, this is r2, and this is the sum sign, okay? And here, remember, it is multiplying, okay? Multiplying over here. So what are these sum signs? So our reoccurrence was ak is minus 4 ak minus 1 plus 3 ak minus 2 equals equals 0, right? This was our reoccurrence. So you will represent AK by R squared minus 4R plus 3, okay? So AK minus 1, you will represent it with R, and AK by R squared, okay? So why? Because it is a reoccurrence of second order, and in the future when I understand better this subject, I will try to explain better the theory and more examples of it, okay? So this is equal to 0. Now R1 and R2 are the roots of this one, the solution for this when it is equal to 0. So let's find them. So 4 plus or minus the square root of 16 minus 12 is 4. So let's just write divided by 2. Okay, so we will have that this is 4 plus or minus 2 divided by 2. So we will have that the first square root is R1 will be 3 and R2 will be, and it doesn't matter if you call R1 3 or R2 3, okay? It will be the same, okay? So R2 will be 4 minus 2 is 2, divided by 2 is 1, okay? So it was one green and one orange, okay? So this is the orange one and this is the green one, okay? So now what was our this one over here? Now in place of R1 and R2, I'm going to put their values, and then what am I going to use? Well, did I? Here. I'm going to use the fact that we know A1 is equal to 1 and A2 is equal to 2, okay? He gave us this information in the question, okay? He gave us this information over here, okay? Over here. This information he gave us, so, okay? So, why am I going to use A1 and A2 to find C1 and C2, okay? 1 second and you will understand. So look, AK is equal to C1 multiplied by R1, but R1 is 3 to the n power, plus C2 multiplied by R2, 1 to the n power, but this doesn't matter, right? Because it is 1, okay? So we can just get rid of it. Now let's use this information over here, okay? So AK, so when let's say, so for AK, for when K is 1, so we'll have, actually we can't use 1, right? I think it gives you the same answer with 1. Yeah, but he's telling us that K must be bigger or equal to 3. This is the problem when you don't understand, like in my case, I don't really understand what I'm doing. I just know the steps. So look, let's use it with A1 and then I will try to do it with other A's bigger than 1, okay? So look, with A1, so it is C1 multiplied by 3, n is 1, so 1 plus C2. Now with A2 is equal to C1 multiplied by 3 to the second plus C2, okay? Now, what was A1 and A2? Well, A1 is 1 and A2 is 2, okay? So this is 2 and this is 1. So now let's subtract so that we can get rid of this one. So 9 minus 6 is 1 minus 3 is 6. C1 is equal to 1. So C1 is equal to 1 divided by 6. Okay. So what will be C2? Well, 1 plus 1. I'm going to use it over here, okay, to find C2. So 1 is equal to 3 multiplied by C1 plus C2. But what is C1? C1 is 1 divided by 6. So C2 is equal to 1 minus 1/2. So it is equal to 1/2. Okay. So this is C2. Now we can have our AK is equal to C1. Well, C1 was 1 divided by 6 multiplied by 3 to the n power. I'm just putting these values over here, okay? We found C1 and C2. This is C1 and this is C2, okay? So plus 1/2, okay? So 3 to the n. Now you need to remember that 6 is 3 multiplied by 2, okay? So this 3 can go up like a -1 over here, plus 1 divided by 2. So you can say that AK is equal to 1 plus 3 to the n minus 1 divided by 2. Now this is the answer that we have in the answer book, okay? Now a problem that we can discuss. We used k equals 1 and k2, but here the k's are not equal to 1 and 2. The k must be bigger than 3. So maybe in another example this wouldn't be correct. So how could we answer this if we did want to follow the rules? Okay, so we could try by solving, finding for a3. Remember that we found that a3 was equal to 5. We can find a4 and a5 maybe, or just a4 will do it. And with a4 we can substitute, okay? Let's do it with a4 and a3, okay? Just to make sure, because here he's telling us that k must be bigger or equal to 3, okay? So a4, what would it be, a4? Now look, a4 minus 4a3 plus 3a2 must be equal to 0, right? So it will give the same answer, okay? But it is better to use 4 and 3 just to make sure in other questions. Maybe it was just a chance. So a4, and remember a3 we did find it, so a3 is 5, is equal to 4 multiplied by 5 minus 3 multiplied by a2 is 2, okay? a2 is 2. Now a4 is equal to 20 minus 6, which is 14, okay? And now we can use the formula, okay? So we have that AK must be equal to what? To C1 multiplied by 3 to the n plus C2, okay? So for A3 we have that 3 to the 3 multiplied by C1 plus C2, a to the 4, 3, A4, 3 to the 4, C1 plus C2. So what do we get with this? So A3 is 5, is equal to 3 to the third is 27, C1 plus C2. So this is just this, okay? Now A4 is 14, which is equal to 3 to the 4, 81, C1 plus C2, okay? So these values of C1 and C2. Now let's subtract them. You have that 4 minus 5 is 9, 81 minus 27 is 54, C1. So we'll have that C1 is equal to 9 divided by 54, which is equal to 1/6, okay? So we have it again. that C1 is 1/6, but I think this is better. Okay, it's better for us to use 4 and 3 because of over here, because of this. Okay, but both of them gave the right solution, so this is it.